Hi. Now here we have two trains, they cross each other in 14 seconds when running in opposite directions. Okay. So these are the two trains, and when they are running in opposite directions, they cross each other in 14 seconds. So let's say the length of the two trains is L1 and L2 and the speeds are S1 and S2, right? So now time taken for the trains to cross, is given as 14 seconds, and we know the time taken for trains to cross each other is the sum of the lengths of the two trains divided by their relative speed. Since they are going in opposite direction, relative speed will be S1 plus S2. Let's call this the first equation. Okay. Next you have the faster train is 160 meter long. Okay, so let's say this is the faster train L1 and this is equal to 160 meter long. So the faster train crosses the lamp post in 12 seconds. So the faster train L1, which is 160 meter long, crosses a lamp post. So let's say this is a lamp post and this train is running at a speed of S1. Now time taken for this train to cross the lamp post is given as 12 seconds. And now time taken by a train to cross a lamp post will be, now in this case we'll take only length of the train L1, since lamp post will have no length effectively, divided by the relative speed. Now since lamp post is a stationary object, relative speed simply will be the speed of the faster train S1. So now since we know L1 is 160, so S1 here comes out to be 160 upon 12. Here I am assuming all the lengths are in meters and all the speeds are in meters per second. So S1 comes out to be 160 upon 12. This goes by 40 times, this goes by 4 3 times. So S1 is 40 by 3 meters per second. Okay. Now the question is, if the speed of the other train is 6 kilometers per hour less than the faster one. Okay. So speed of S2, now S2 is 6 kilometers per hour less than the speed of S1. But since speed of S1 we have calculated is in meters per second, so let's convert this 6 kilometers per hour into meters per second. And the way we convert kilometer per hour in meter per second is by multiplying it with 5 by 18. So speed of S2 will be S1, which is 40 by 3 minus 18 goes by 6 3 times. So this is 5 by 3. So speed of the other train, second train or the slower train, comes out to be 40 minus 5, 35 by 3 meters per second. Okay. So we have this so far. Now the question is, what is the length of the faster train? So now to calculate length of the faster train, let's make use of this equation. We know 14 seconds is equal to L1, length of the first train, plus L2, that is what we need to figure out, upon S1 plus S2. Now S1 is 40 by 3 and S2 is 35 by 3. So 40 plus 35 is 75 by 3 meters per second. That is S1 plus S2. Now 75 by 3 is effectively 25. So we have 14 into 25 is equal to 160 plus L2. So L2 comes out to be 14 into 25 minus 160. Now 14 into 25 will be 250 plus 100, 350 minus 160. So 350 minus 160 is 190. So length of the slower train is 190 meters. So the correct answer here is option C. Thank you.